Okay, today's lesson is on section 3.6, multiplying matrices. So how do you multiply matrices? Well, here's the deal. To multiply matrices, the number of columns in the first matrix needs to be equal to the number of rows in the second. Otherwise, we cannot multiply them. So if you remember to the last lesson, if I write the dimensions of a matrix, the first number is the rows, and the second number is the columns. So if I have a 4 by 3, 4 row by 3 column matrix, and I want to multiply it by a 3 row by 2 column matrix, can I do it? Well, I have to look to see if the number of columns in the first is the same as the number of rows in the second. So in this case, you can see that we would be able to multiply this matrix. Now the new matrix, the resulting matrix, the dimension is the rows in the first by the columns in the second. So the new matrix is going to be a 4 by 2 matrix. Four row by 2 column. And we'll do some examples here. Okay, how about the second one? Can I multiply it? Well, the columns in the first is not the same as the rows in the second, so we cannot multiply. Okay. How about this one? Looking at this, yes, the columns in the first are the same as the rows in the second, so we are able to multiply it. My new matrix is going to be a 2 by 1 matrix. Okay, so now let's actually do this kind of a problem. Let's take a 2 by 2 matrix here, multiply it by a 2 by 1 matrix, and see what we get. So this is how we multiply. You multiply the rows in the first by the columns in the second, and we basically what we do is we multiply and add. So I'm going to create a matrix here. So we're going to multiply negative 2 times 3. I'm going to write it all out here. Plus, now I go over in the first and down in the second. 3 times 2. Okay, so that's the first row, or the first entry there. Now I move to row 2 and this column. 5 times 3 plus 1 times 2. And now my new matrix, I just have to do the math here and see what I get. So this is negative 6 and 6. So negative 6 plus 6 is 0, and 15 and 2 is 17. So my new matrix has those entries right there, 0 and 17. So you can see that the actual dimensions of the new matrix was 2 by 1. Okay, so let's do some more complicated examples here with some more numbers in them. Let's take a 2 by 2. And multiply it by a 2 by 2. And see what I get. Now to make things easier for me, what I like to do is label the rows in the first. I'll call this row 1, row 2, and label the columns in the second. And then my new matrix, if this is a 2 by 2, this is a 2 by 2, my new matrix will also be a 2 by 2. So I'm going to label this R1, R2, C1, C2. This is just going to help me keep organized. So when I take and multiply row 1 times column 1, it's going to go in the row 1, column 1 location in the new matrix. Okay, so I multiply across and down. I got negative 3 times 1 and 3 times negative 3. So I'll write it out in this one. Might not have enough room. I'm going to actually make this just a little bit bigger. Okay, so that's row 1, column 1. And I'm actually we'll just go through it and write the answer down. here. So I got negative 3 and a negative 9 is negative 12. Row 1, column 2 is going to go in the row 1, column 2 spot right here. Negative 3 times 5 plus 3 times negative 2. So that's going to be negative 15 and a negative 6 is negative 21. Okay. Row 2 times column 1 is going to go in the row 2, column 1 location. 1 times 1 plus negative 2 times negative 3. So that's going to be 1 and a 6, so that's going to be 7. And row 2 times column 2 is going to go here. 5 times 1 and negative 2 times negative 2. So I get 5 and a 4 is 9. So that's my new matrix. Okay, let's try another example. Start the page here. Let's go with a little bigger matrix here. Here's my two matrices. Now, first question is, can I multiply these? Well, this is a 3 row by 2 column matrix. This is a 2 by 2. So, because the columns in the first are equal to the rows in the second, we can multiply it. The new matrix is going to be a 3 by 2. Okay, so I label the rows in the first and the columns in the second. And I make a new matrix that's a 3 by 2. And we multiply them. Now let's see if we can do this math a little bit more in our head without writing them out. So I'm going to take row 1 times column 1 to put here. So I've got negative 1 times 3 and a 2 times negative 2. So I get negative 3, negative 4 is negative 7. Okay, row 1, column 2, negative 2 and a negative 2 is a negative 4. Row 2, column 1, negative 9 and 0. Row 2, column 2, negative 6 and 0. Row 3, column 1, 12 and a negative 2. And then row 3, column 2 is 8 and a negative 1, which would be 7. Okay. So that's a 3 by 2 and a 2 by 2. Let's do one more here. Let's go with a 3 by 2 and a 2 by 3. Let's see what happens. Okay, so I have a 3 by 2 and a 2 by 3. So you can see we can multiply it. The new matrix is a 3 by 3. That's a big matrix. Okay, so we'll make that here. Label rows here. Okay, so now I'm going to take row 1, column 1. So I get 3 and or 0 and a negative 15. Row 1, column 2, 3 and 25. Then I get 15 and 0. Row 2, column 1, 0 and negative 6. Then I get negative 1 and 10. Then I get negative 5 and 0. Then I get 0 and negative 15. Whoops. then I get 0 and 25 and 0 and 0. So that's what I would get there. Okay. Alright, so one last thing, I want to show a quick application. To make it a little quicker, I'm just going to refer you to page 198 in your textbook, and we'll look at that example real quickly here. Use matrices to calculate total cost. So business can calculate total cost using matrices. Basically, we take the inventory matrix, multiply it by the cost per item, it'll give us our total cost matrix. Okay, so let's look at example 4 here. Okay, so we've got 2 sports hockey teams submit equipment list for the season. You got hockey sticks that cost $60, pucks are $2, and uniforms are $35. Okay, so, and they've got their equipment list right here. The women's team and the men's team, what equipment they need. So they create an equipment matrix here. They've got the women's team and the men's team. They've got the number of sticks, pucks, and uniforms that they need. They have a cost matrix here for the cost of sticks, pucks, uniforms. So you can see that the labels on the columns have to be in the same order as the label on the rows for the cost matrix in order for this to work. So if I multiply the inventory matrix times the cost matrix, I'm going to end up getting the total, the cost per item matrix will give me the total cost matrix. Okay, so here's the math here. We're taking a 2 by 3 and a 3 by 1, so the resulting matrix is a 2 by 1. Now one thing that this is different than any of the examples I did, this row times this column is 3 separate multiplications. 14 times 60, 30 times 2, 18 times 35. You have to add all 3 of those up to get your resulting matrix entry there. So this row times this column gives me this entry. This row times this column gives me this entry. This is going to basically give me my total cost matrix, which is the total cost for the women's team and the total cost for the men's team, as shown right there. Okay, so that's a quick example. There are a couple in your assignment that you'll have to do similar to that. So that is the end of section 3.6.